So thank you very much for joining our webinar. Today it will be a bit more nerdish and technical than usual because we are going to dive deeper into architecture of UgCS and talk a little bit about opportunities that UgCS gives to developers. So different extension points, what can be customized. Of course, it is not possible to cover all these topics, but my goal of this webinar is to give a better high-level understanding on what is possible and what is not. So after that webinar, we could discuss with those who wish to make customizations. We could have a good conversation. So again, so that's the main question for our today's webinar. What if your business requirements not fit into the out-of-the-box functionality of UgCS? So, yeah, what shall you do and what options do you have? So first of all, let's walk through a list of most typical questions that we receive from our clients. So let's just go one by one. So the first is what shall I do if my drone, my custom drone, is not on the list of drones supported by UgCS? And indeed, what shall you do? Because we provide, of course, we provide a lot of drones out of the box, but sometimes you have an autopilot which is not supported by our software right now, or you might have capabilities of the drone, maybe some subsystems that are not properly reflected in the user interface. That's the first thing. We are going to speak about all these topics in more detail on next slides. So, in another case, sometimes you need to integrate your drone control system with some external software. For example, you might need to integrate drones into security system to automatically respond to some alerts or events generated by this third-party system. Also, you might want to integrate the video subsystem of the drone into video surveillance infrastructure. Sometimes you need to log your drone telemetry, maybe to log it, or maybe to send it to some third-party traffic management system or fleet management system. So that's also a very, very common task. Sometimes you need just to have a distributed ground control software. So you need to have pilots in the field. You need someone in the control center, some supervisor who can control the entire operation, and that's also a very, very common request. And of course, you might want to integrate some custom payload with your drone and properly support it in the ground control software. So these are the most common requests that we receive. So how can we address these questions? First of all, you need to understand the architecture of UgCS, because that's the key for proper decisions. So, because when you have some problem that you need to address, for example, some integration task, of course, you need to understand what are the extension points of the software that you are going to integrate. So let's walk through this architectural diagram. I hope it is clearly visible for you. But anyway, if you cannot see it well on my slide, you can always visit sdk.ugcs.com and you will find the same diagram in the architecture section. So UgCS consists of several layers and many modules. So when you run UgCS on your laptop, in reality, there are many components which run simultaneously on the background. So it's not just a standard desktop application consisting of a single executable which works in your interactive session of operating system. No, it consists of many processes. And that was designed intentionally from the very beginning because we always had in mind different scenarios. Such scenarios when you need to substitute a certain model, when you need to integrate with a certain module just to integrate a certain model into more complex system or have a distributed installation. That's why UgCS consists of so many separate processes. So let's walk through this. Let's walk through this blocks. So we will start from the central point. This box that we call UgCS control server. That's a core part of the software. So it performs the flight planning activities. So when you draw some route in the user interface, and then you get a trajectory with, for example, terrain following, the trajectory is calculated on this control server. That is a component that runs on the background, and also it provides storage capabilities, data validation, and it serves like a central point that communicates all other components between each other. Then we can, can you see my pointer? I hope that will be better. So let's look at the bottom of this diagram, where we have UgCS.NET SDK. So these components reflect applications with user interface. So the most known component is UgCS Desktop. That is something that if you are a UgCS user, then you use this, most probably you use this component on a daily basis. That is software with a 3D map that you use for flight planning, for controlling your drones. Another component which is included into our enterprise package is a video player. And another component is a custom payload monitor that's a part of our industrial solutions. But one thing which is common for all these components is that all these components communicate with control server. So they receive telemetry, they send commands to the drones through the control server, and they render some presentations for the pilot. So, and for communication with the control server, these components use our .NET SDK. So when, for example, you need a custom client, I don't know, if you need a simplified application for someone with a 2D map, with only a few buttons that will do just a drone takeoff and will automatically send drone to some point, You can build your custom client using .NET SDK. Then, let's see what else do we have here. At the same level with UgCS control server, we have also other server components. First of all, a UgCS video server. This component provides video streaming capabilities. So for example, when you use our mobile application, for example, UgCS for DJI, and you can configure video streaming from this mobile application to our video server. And this video server can reside either on your laptop or it can be deployed somewhere in your data center. So this mobile application will stream video feed over the LTE connection. Another component is a geo server. Again, it works on the background of every UgCS installation, and it stores all the special data. So it stores tiles, makes an offline cache for tiles. It stores, when you upload a GeoTIFF with elevation, it resides on the geo server. When you upload any KML data, with place marks, this data is been stored on the geo server. So this is a quite useful component. So for example, if you need to access some special information, then you can access this information. Then you directly use the REST API of GeoServer to access some special data, or you can get, for example, elevation in points, or make some simplified operations through the UgCS control server. Okay, then let's move upper. On the upper level, we have these two blocks. And this is something that we call VSMs. VSM stands for Vehicle Specific Module. So Vehicle Specific Module is an adapter between the ground control software and the drone. So on the Vehicle Specific Module level, we implement a custom drone protocol. And Vehicle Specific Module can be implemented in different forms. In case of DJI drone, it is implemented as Android application and iOS application. In case of other drones, like Ardupilot based drones or Pix4 based drones, it's just an executable that runs on your laptop. And it is possible to implement your own vehicle-specific modules. For example, when you have an autopilot which is not supported by UgCS, or when UgCS does not support all the features of a certain autopilot, you can implement your own vehicle-specific module. And in our GitHub account, we have several examples of such vehicle-specific modules. So, for example, we have published the source code of Ardupilot VSM and Pix4 VSM, and also our VSM C++ SDK. And also the communication protocol between control server and VSM also published as a separate document. So if you are not satisfied with our C++ SDK, for example, you can just take the protocol and build everything from scratch. Next, so on the top level, we have a drone, and for most of the drones, so all the communication ends when the VSM, so on the VSM level, meaning all the software components, they end on the VSM level. So because after VSM level, typically we just work through the standard data link. In case of DJI drone, this can be a remote controller, which is connected to our Android application. In case of other drones, this can be a data link, which is connected to the computer with UgCS software. So, but sometimes you also need to add additional functionality to the drone. And in this case, you might use components that we implemented for onboard computers. So in case of DJI drones, we have a special implementation of our VSM, which can be installed to the onboard computer, which is connected to the DJI Onboard SDK port. And these component, for example, can be used when you need to control your drone over the LTE network. Also, we have a separate component which can make a video streaming. But it's not just an ordinary video streaming, which already implemented in most of the drones, but it allows you to integrate the video feed with telemetry coordinates. So at the very end, you get a MISB compliant video feed. And these components can be installed on such computers like NVIDIA Jetson Nano or Raspberry Pi. So depending on the task that you are performing, or either just drone control, or for just an ordinary drone control, you might use Raspberry Pi because you don't need a powerful computer. But for video streaming, we recommend to use a more powerful thing. Based on Jetson Nano, for example. Okay, this is a high-level architecture of our software. Let's go directly. One more slide about SDK, available SDKs. So just one more time. So we have a .NET SDK, which allows you to implement your own client applications. We have VSM C++ SDK, which allows you to connect drones not supported by UgCS at the moment. We have a version of Android mobile SDK, which works with DJI drones. And you can rebuild your own mobile application. We have also a set of video streaming SDKs, which can be used either on board or on the ground to encode video and generate video stream with georeferencing, MISB compliant video stream. It's also called a full motion video. If you're familiar with Ardupilot, for example, they have such a thing like a full motion video. So, and with video streaming SDK, you can generate such a feed. And we also have DJI Onboard SDK adapter, which allows you to control DJI drones through their onboard SDK. This allows you to overcome different limitations of their light. Okay, so let's walk through the list of cases, and I will briefly explain the problem statement, and then I will give you the recipe how you can address this problem. So one more time. So what to do if the drone is not currently supported by UgCS? In this case, depending on again, the level of support can be defined as following. So if the drone has a compatible autopilot, then you might need to implement some additional client components. For example, if you have a complex drone, then you might need to add and visualize additional telemetry fields. If the drone, and you can use .NET SDK for that. If the autopilot of the drone is not supported by UgCS at all, then most probably you will have to implement a custom vehicle-specific module. This is an example. So a complex drone which has additional subsystems and telemetry fields which are not supported by a standard UgCS client. And for this case, we implemented a separate dashboard for telemetry. Here on the right, you can see it's a simple application based on our .NET SDK. We added this application to our UgCS 4.0, and at the same time, we published this application on our GitHub, so you can always check the source codes and implement something similar, or just take this application and modify it. Then, how to integrate security system with a drone? A typical scenario that we observe is the following. So perimeter security system has different sensors, and sensors have known coordinates. So when a certain sensor sends an alert to the perimeter security software, the software can you typically want to send a drone in the vicinity of the sensor to inspect what happens. So with .NET SDK, if security system supports any integrations and you can subscribe to such events like security alerts, and as a part of this event, you can receive the coordinates of the area where sensor triggered, then you can build a small application using our .NET SDK, which on one hand will listen for such events, and when such event happened, it can automatically generate a mission for the drone. And if drone is connected to UgCS, then it even can upload this mission to the drone, arm it, and send to the location of the incident. So again, in our GitHub, you can check the sample application, which shows you how to build a simple mission, how to subscribe to drone telemetry. So you can use it as a basement for your further developments. Next, again, how to stream video from drone to a video management system. Depending on the drone type, you can use several components. So if you're working with DJI drones, then our mobile application can stream video to our video server. And this video will be with georeferencing, as I already told. So then you can either consume the video feed from our video server. We can provide RTSP video feed from our video server that can be used by most of the video management systems. And that's the first type of integration. The second type of integration is when you have a drone, for example, Ardupilot based or Pixel based with some custom camera, and this drone doesn't provide such an integrated video streaming hardware like DJI does. In this case, you might want, you may have a separate video link connected to a computer, and we have a software component that can be used to grab this video feed and then again send to our video server, and our video server will provide endpoint for a video management system. So that's the essence of the fourth case. So when you have a Pixel-based drone and some custom camera, then you can use this combination of our video transmitting desktop software and video server. So, and this is an example of video transmitter software that can run on the desktop computer. Again, this software is published as an open source application on our GitHub, so you can check how it works and how it communicates with our video server. So you can reuse it for your own development. And this is a diagram how it typically looks like. So you can have this video transmitter component in the field, and you can have a video server in your command center integrated with, for example, a milestone video management system. So this is a diagram from a real project which we implemented together with our partners to a customer in Latvia, and for that specific project we used a non-DJI drone. The drone was from Video Drones. It was quite successful project. So the last case, how to integrate the drone into LTE and 5G network. So again, you can use, in most cases, you need onboard computer that will run either, depending on the autopilot, it will run either our components, our adapter for DJI Onboard SDK, or it can run Ardupilot VSM or PX4 VSM. So you can obtain all these components from us. For example, if you have such a project, and build a drone that will be that will connect to UgCS ground control software through some network, not through the standard data link, but through some IP network, LTE or corporate Wi-Fi. That's possible to do, and that's what we recently implemented together with LMT, the communication provider in Latvia. There was a cross-border flight with DJI M600 controlled by additional onboard computer, Raspberry Pi, which executed our code for a DJI Onboard SDK. So that was quite impressive. So now I want to answer several questions that we received before this webinar. And after that, I will answer questions from Q&A section. So, and here are the several questions that we received. So how to get drone data out of API with Python? For now, we do not have bindings for Python language. I suppose that it is possible to do, but for obtaining telemetry, we recommend to use our .NET SDK, or as an alternative, we can provide Java SDK. Next question. Can an open discussion forum be created for developers using UgCS SDK? Yes, that's what we plan to do. So I hope in next couple months we will open this forum where we can discuss different topics, share knowledge, and answer questions. Can we integrate with ArcGIS full motion video to get live georeferencing to mark waypoints and that nodes directly into database? Yes, with our video streaming, you can generate full motion video for ArcGIS, and then you definitely can use this video for making waypoints and making any notes and annotations. Next question. Is the UTM integration based on GUTMA proposal? Now, we do not provide any SDK for UTM integrations, but if you have a task of integrating UgCS with some UTM system, then you can definitely start from exploring our .NET SDK, because the component that will synchronize your ground control software with UTM system can definitely be a separate application, and you can use .NET SDK for that purpose. And the pricing of support. So most of the SDKs will be provided as open SDKs. They will be available on our GitHub account. And if you have questions which are not covered with our documentation, but just which have to be in this documentation, we will answer these questions just as a part of our standard support. If you will have questions that will require some additional analysis or some custom development from us, or some or providing some consultancy services and involving our development team, then we can consider such things as custom development projects or consultancy projects. We are always open for such types of cooperation. Now I'm going to disable pointer. I'm going to answer questions from Q&A. The question from Jeremy: where are the source codes and documents published? Where can we find them? So source codes, all source codes are available in our GitHub, github.com/UgCS. Most of the documentation is available through our sdk.ugcs.com. This site is pretty new, and we are going to add more materials in the next few weeks there. So just check it from time to time, and of course we will send updates to our users about new releases of our SDK. But basically, these are two main sources of information: our GitHub and our at github.com/UgCS, and our webpage at sdk.ugcs.com. Another question is Another question from some anonymous attendee. How does UgCS for DJI work with other Android hardware platforms than standard tablets such as Odroid or RPI? We do not put a lot of effort for testing such unusual configurations. So we know for sure that for Onboard SDK, for example, for the project where we had to fly on M600 with LTE connection, we used RPI, and our adapter for DJI Onboard SDK ran on Raspberry Pi, but we do not try to run our mobile application with user interface on such a hardware. So again, if you have some specific project that requires some configuration, we definitely can discuss it separately, but it's always nice to understand what are we trying to achieve. Yeah. So seems like that's all. No more questions. So you can always post us questions either to my address directly or to our support team.